Hi, everyone. Welcome to today's webinar. Thank you so much for joining. As Chris said, I'm Pablo. I'm part of the product marketing team at Semgrep. I've been with the company for a number of years. And prior to this, I had some experience working in security and cybersecurity, as well as network infrastructure and electrical engineering long ago before that. So thank you for coming to learn about common vulnerabilities and how secure guardrails can help. As Chris mentioned, it's definitely been something that's been top of mind for us and many of the people that we speak with. So I'm excited to share some of those learnings that we've seen over the last few months with you, and also learn from you what some of the challenges and maybe opportunities or things that you're excited about in your security teams and organizations might be. So let me share my screen here for a second so we can get started. Okay, yeah, so maybe to start off a little bit with why are we talking about common vulnerabilities and what are secure guardrails and how they can help? Yeah, this is, we had a little bit of fun with this webinar theme and title, but it's really rooted in something that we've seen security teams deal with, not necessarily struggle with, but definitely have to face, and that is the pattern of kind of people having to deal with the same type of vulnerability kind of over and over and over again. And some of you who are familiar with the history of OWASP Top 10, for example, may recall that back when the OWASP Top 10 was first published, I think in 2002, maybe 2003 or so, XSS, cross-site scripting, was one of the things on the top 10, and it's still there today, 20 years later or so. So of course, technology has changed. Programming, software development has changed a lot, and yet we still see a lot of these things that are repeating, kind of like face teams and people having to kind of learn or relearn the same lessons again. So that's a little bit of the background, and something that we see really with the customers and organizations that we work with today. So the agenda for today, first we'll talk a little bit about shift left. That is important to really set the context for secure guardrails and talk a little bit about how we got to where we are today. We have a couple of one-question polls just to get a bit of understanding of how you view shift left and maybe some of the things that you've done in your organization related to that. We'll also share a bit about what is the state of the art in secure coding. What are people doing these days with addressing common vulnerabilities and secure guardrails? And there are other terms that we'll talk about briefly that you may have heard of as well that are related to this. And we'll also get into the practical matter of like what can people really achieve today, and what are people achieving today, and how can people get started or make progress with secure guardrails. We'll briefly touch on secure guardrails with Semgrep. This is not a product demo webinar or kind of like showing off the platform. We're definitely happy to show it off more to you at another time. But I just wanted to give you a glimpse of what we're doing with respect to secure guardrails in the Semgrep platform. And then we have a bunch of links at the end that you can use to follow up later if you want to learn even more. And we will have a little bit of time for Q&A at the end. But if you do have questions, please enter them into the chat, and Chris can help answer them. I will pause occasionally and look over at the chat, see if there's anything going on there. If this is very interactive, that'd be great. Hopefully we can all learn from each other, and then it'll be even more productive for everyone. Okay, a little bit about Semgrep in case some of you are less familiar with who we are. Semgrep is an AppSec platform for secure guardrails. That includes SAST, SCA, and secrets detection. It's a platform that's transparent, customizable, extensible. We'll talk about how that relates to secure guardrails a little bit later. And some of you may be familiar with our open source project, which powers over 10 million scans per month. There are many, many innovative organizations that depend on Semgrep in production. Those logos you see there are just a few of them, and we are backed by some top-tier investors like the ones you see at the bottom. We are based in San Francisco, but like many companies these days, we have people kind of around the world. And I think it's really, to me, it's important to just briefly touch on the Semgrep mission, and that is to profoundly improve software security and reliability. This webinar is not about our mission or kind of like the loftiness of this goal. We do think it is very important, and it really shows up in how we develop our product and the areas in which we choose to invest. That's why I think it's important. It's really something that I think has caused everyone at Semgrep to, in large part, to join the company and brings us to work every day. And we really believe that concepts and initiatives like secure guardrails are really helping us move in this direction. So I just wanted to point that out. That's something that's really in the back of our minds all the time. So let's discuss a little bit about shift left and how we got here. So this webinar is not really about shift left. That's not why we're here, but it's important to have a common understanding of what shift left is, because it is related to secure guardrails. And I'm going to guess that everyone in the audience has certainly heard of shift left and probably has dealt with it in some way. And for better or for worse, I think it's the term shift left has really gotten a negative connotation in the industry. People that I've talked to, some of them feel a little bit burned by shift left. Some of them maybe feel like the term had a lot of promise, not a lot of kind of fulfillment of that promise. And it's become somewhat of an empty term. Like many buzzwords, if you consider it a buzzword, it does have some core elements that were really good and promising and valuable. And so we want to touch on those and really get to the essence of what is shift left today and how are secure guardrails different. So before we get into that, I'd really love to ask all of you a question with respect to shift left. Do you think it's a useful concept? It's a buzzword somewhere in between? Or if you have something else to say about it, please enter it into the chat. So Chris is launching the chat, and I'll give everyone a couple of moments to select that. Okay, we have a number of votes already in. Almost everyone. I'll give people a couple more moments to choose something there. And then Chris will close it here in a moment. Okay, let's have a look at what you all said. So somewhat surprising to me. The breakdown is as follows. Useful concept, 28% of you marked that. Buzzword, 0%. That was one a little bit surprising to me. And somewhere in between, not too surprising, 68%, definitely the bulk of it. So that's definitely very helpful for us to understand. And thank you for sharing that. I think the things where we've seen people struggle with shift left are really not around the promises or the ideal case. This is a little bit paraphrased, but in many ways, the promises of shift left were that it would make software development faster. It would make vulnerabilities cheaper and faster to remediate. Software would become more secure. And that all sounds pretty great. I think it's something that these and similar things that were kind of shared with or are shared around shift left. Yeah, this is what many people are looking for. Definitely security teams these days are outnumbered by their software developer counterparts, and teams need to find ways to scale and secure the increasing surface area of their in their purview. And shift left was definitely something that's appealing. I think what we've found in many cases is that shifting left is often associated with early surfacing of security issues to developers. Now, I realize shift left is something that's not unique to security. It's used in other parts of software development. In the context of software, many people really equated shifting left with bringing issues to developers early on in the process. That is definitely one part of shifting left, and certainly an important part. I mean, it's basically in the name itself, by definition. But unfortunately, what we've seen is that if it's just really relying on this aspect, then shifting left can be quite unproductive at times, and sometimes even actively harming the relationship between security teams and development teams. And I think that's what many people that I've talked to, at least, when they mention that they feel a little bit burned by it, is they kind of were expecting something else, or that it would play out differently. And I think a large part of some of the disappointment that has come with shifting left is because fundamentally there are some misalignments between developers and security teams. And one is that ultimately developers are incentivized to ship software, not to fix security issues. And sometimes developers may be expected to some degree to have deep security knowledge when they're asked to remediate or address a security issue, when in fact they don't. That's not to say they don't have any training in this area or they have no knowledge of it, but they don't necessarily have that same security expertise, background, and mindset that we often see in security teams. And also the tooling itself. When things are kind of shifted earlier into the developer's process, that means shifting into other parts of the developer workflow, and developers really hate leaving their workflows or kind of being disrupted in that way. So getting really issues early on or earlier into the development cycle is not really that difficult. I think the difficult part is making it so that those issues that they see are easy for them to fix, that they are actionable, that they don't require some kind of like very onerous change in workflow or kind of knowledge that they need to build up in order to address the particular issue. And while there are many tools and many ways that one can bring security issues to developers early on in the process, it's actually quite difficult to make it easy for developers to fix those issues. And we think that together, kind of addressing both of these together, those form the essence of secure guardrails. And we'll talk a little bit more in a bit about how that plays out and what does it mean to have something that's easy to fix and not disruptive into a workflow that developers have and really treasure. But that's something that we've found to be really missing when we talk to some of the folks who are a little bit frustrated with shifting left, or they just say like it hasn't really played out in the way that they initially expected. So very curious now to ask our second poll. So there's only 2 polls here, but I'm wondering for all of you in the audience in terms of rolling out shift left, especially since there were a good chunk of people who answered, I think 68% who answered somewhere in between in the previous poll. I'm wondering how far along is your organization with the rollout of shift left? So Chris has opened the poll. Thank you, Chris. And I'm just going to leave it here open for a number of moments. And in the meantime, I'm going to pull up the chat. So Patrick asked, can you ever fully implement it? Yeah, I think that's a great question. And Patrick, maybe if I'll leave the poll running for here just a moment more, if you wouldn't mind answering, like, is there any one aspect that stands out to you of like, well, I don't know if we'll ever get to this part of fully rolling it out? Okay, and then while, yeah, I think you can always go further. Yeah, definitely. I think in many aspects of it, you can go further. For example, making it easier for developers to fix issues, improving security education in the first place. Just even outside of the context of secure guardrails. Thanks for that comment. So the poll. Thank you again, everyone, for responding. So, have you tried implementing shift left? 60% of folks said we made some investment but didn't roll it out fully. 27% yes, we fully implemented it. fully implemented it, and no was 13% who didn't. So thank you again. Yeah, I think Patrick's comment is spot on. There's definitely always more that you can do. And I think in some ways, what we're talking about here with secure guardrails is really not, there is a lot of overlap between secure guardrails and shifting left. And so one way to think about it is as an evolution of what started off as shift left. And now with what we've learned in the industry and, kind of like rolling it out through different organizations, what we've seen is that secure guardrails can definitely be considered or seen as an evolution that kind of came out of shift left and is taking, yes, some important parts that maybe were missing in some cases in some organizations with respect to the shift left way of rolling things out, but ultimately it's kind of with the same goals in mind. So great, thank you so much for those comments and that poll. So maybe it's worthwhile then pausing and thinking about, well, why are we considering secure guardrails in the first place? We're kind of even regardless of how much you may or may not have rolled out shift left, or whether you think it's a buzzword or there's definitely real value in it. And I think this goes back to what I mentioned at the very beginning of the webinar with respect to people really playing the what's often called the game of bug whack-a-mole, kind of going back and over, repeatedly having to address the same common vulnerabilities or vulnerability types, and kind of chasing down the vulnerability backlog, essentially, which these days seems to be growing more and more. And as people make releases and shift software and the backlog grows and security teams need to triage and kind of like whittle down that backlog, etc., and then the cycle kind of repeats. Sometimes people feel stuck or like they don't have the ability to take control of that backlog. And so we think secure guardrails is really a novel, and maybe not so novel, as we'll get to in a moment, but a really great approach to help teams gain control of that backlog, to make software more secure, and to help software developers not only aid in that security objective, but also meet their goals, which is often related to shipping software and shipping it quickly. So I think it's worthwhile to look at a few examples of what some leading organizations have written or said about secure guardrails or similar topics. So I'm using now secure guardrails a little bit loosely because as we've seen the research from different organizations, there are some terms that are kind of used in similar ways. I'm not saying that they mean the same thing, but you may have heard of things like the paved road or paved path, secure guardrails, secure defaults, etc. So we'll be talking about those here in this section. Many of you may be familiar with this book by Google, Building Secure and Reliable Systems. It's not a short book. There's a lot of great info in it, but I just wanted to call out a few things that they note. The first is that they say it's unreasonable to expect developers to be experts in these things. And now they're talking about reliability, maintainability, security, all these things, but certainly applying to security as well. And it's unreasonable to expect them to be experts and to constantly maintain vigilance when they're doing their core job, which is writing or reviewing code. And so that's one important thing related to what we said earlier about kind of the level of expectation of security knowledge that is asked of developers. And the second one is really the approach that they recommend, where they are trying to find ways that make writing code with the common classes of security vulnerabilities impossible. And that's also very interesting and very aligned with one of the objectives of secure guardrails. We're looking at ways that we can address these common classes of vulnerabilities in a systematic way, so that they don't appear anymore, or in large part appear anymore. I'm not going to claim that this is some kind of silver bullet, but it is something that I think we'll see in a second, we can make meaningful progress towards doing that. Another good example is to look at is Facebook. And they have what they call a defense in-depth model. They have a really nice post about this called Designing Security for Billions. And on the right side, you'll see an inverted pyramid of vulnerabilities. beetles or some kind of bugs that starts at the bottom, or sorry, at the top, at the widest area with secure frameworks. And that's what they use as their kind of building blocks for all of their software. And they're saying that they're investing in these frameworks to remove entire classes of bugs. Now, you see, as the bug diagram shows, it's not removing everything, right? There's only some that are eliminated, even if it's maybe a little bit more than half. And then they're also still relying on automated testing tools, peer reviews, red team exercises, bug bounty programs, etc. And but it's still an important foundation to help all the other steps that come after it, and ultimately greatly reduce the number of bugs that they see in their software. And then finally, one other kind of resource I wanted to point out. This is a little bit of a newer paper from Google, published in March, and called Secure by Design, not nearly as long as that other book that I mentioned earlier. And I think this is a great paper. It really talks about how to design and keep a safe developer ecosystem. And they talk about some key things, such as security that's based on invariants. And in this case, invariants are things that they know to be true because they've designed the thing to be that way. And they, in a very related way, when they design their software using these principles or maybe like base components, then they know that any program is going to, that they have running, is going to uphold with these security invariants, and is going to be free of any vulnerability that's related to those invariants. And the way that they describe it, I think, is interesting. They say something like, if the code is not secure, then it won't compile. Now, of course, that only applies for some programming languages and environments, but I think that philosophy is really interesting to think, like, if it's not secure, it's broken, basically. And then the other thing that is really interesting, and we've seen also at several other organizations that we work with, is that there are teams that are providing what they call well-lit paths. I think maybe they're looking for a phrase that's different from the paved road. Well-lit paths for apps of an archetype. So maybe there's a web app that has some number and types of microservices. It has some database. So they are providing these kind of common standard building blocks. So if a team wants to stand up a new app, a web app, that has these kind of like features in it or requirements, then they will be provided with a standard kind of like archetype for that. And of course, then they'll build their software and customize it to achieve what they need to do with that. But that kind of baseline is very interesting, and something that we've seen also at other organizations. Okay, let me see if there are any comments in the chat. If there's any questions or any comments that you have about these, please let us know. We're happy to share links to these different resources and papers that we are sharing later on as well. One thing that you may be thinking is, okay, that's great for Google, Netflix, who popularized the term paved road or paved path, or Facebook/Meta. It's great for them. They have a lot of resources. I'm sure the security teams are well funded, but not everyone is in that situation. So yeah, I think that's definitely something important to consider, and that's why I wanted to touch on what's practical today. Like, what can people achieve? What are people achieving today outside of these organizations? I think there's a lot to be said from just having a thoughtful approach to the choices in frameworks and libraries. And there's some examples here of some libraries, tools, packages that really are kind of steering people in this direction of secure guardrails, and not requiring the software developer to think about all the edge cases with respect to how they're using the library or tool and the security implementations that may come from different uses of that tool. And another thing to consider is that, yes, the companies that I just mentioned before, they do have a lot of resources, and they can definitely invest a lot of attention and time into this, but they also have the challenge of actually trying to or needing to like influence the behavior of a very, very large organization. So in some cases, being much smaller than a Google or Facebook is an advantage, because you don't have to convince 20,000 plus, or however many there are, tens of thousands of engineers to do things in a different way, and you can actually make progress rolling it out or educating your counterparts and stakeholders in these areas much more efficiently and quickly. So that's just something to consider. I personally really like the Go examples also at the bottom. Recently, Go published a few of these packages, like safe archive over archive zip. There are similar kind of equivalents in other languages as well, like YAML, YAML deserialization and loading and stuff like that. So there are things that you can do in terms of like choosing, recommending, promoting these frameworks and libraries that will make an impact and make a difference and are really aligned to this way of thinking. There's also a great example from DocuSign. DocuSign gave a talk at an event a few years ago. I think it was called Banning Foot Guns. And in this talk, they described their secure by default methodology and the libraries they use to for which they enforce use of, and they're using those in order to eliminate these common vulnerability types like XSE, denial of service by regex, open redirects, etc. And the kind of summarized but step-by-step methodology that they kind of are using here is to like find the bad pattern, make the safe pattern the default one. And I should note, this is something, number two, is something that other people talk about as well. Netflix comes to mind in one of their talks, where they're really proponents of making the safe pattern also the easier one. So default may also imply easy, but in terms of developer experience and developer UX, making the safe thing the one that's most accessible, easiest to find, well documented, and making it so that if someone were to choose to do something else, they would really have to go out of their way. Training developers to use a pattern. Certainly, this is not all about tools and libraries and frameworks. Education is definitely a very important part of security in general, and including secure guardrails. And then building tools to enforce the new rules. That's a little bit more on the application security or security teams themselves, in terms of how do they know and how do they track that people are actually using the things that have been shown and recommended to them and they've been trained on. And also to kind of like understand what impact the use of those things is having on overall security. So that's also an important thing to do more on the security team side. We also thought to ourselves, what is it that we can measure to see how effective are secure guardrails in practice? Now, there's a whole different talk on this. We did some research. Our security team did some research on the effectivity of secure guardrails to prevent XSS vulnerabilities. So they did a study of open source code, I think analyzed over 3,000 commits across 9 different programming languages, or kind of frameworks / programming languages. And really, this is kind of trying to understand how effective are secure guardrails in practice, and also coming from the angle that it can be a lot easier to detect the use of an insecure library, rather than when something is more kind of like baked in and later in the process, or one needs to actually try to find a bug, confirm it, and maybe even write a proof of concept of an exploit. Those things take a lot more time and effort and probably require different level of skill. And while this vertical access is just kind of hand wavy, let's say, it is definitely easier to detect the use of an insecure library rather than spending the time and effort to, say, write a complete proof of concept for an exploit. So that's really what we're trying to get at here, is like, okay, this approach can be a lot easier, and would it be effective to, in the case of the study, to prevent XSS as a way to measure if or how effective secure guardrails could be. So actually, through the research, we found that using secure guardrails could have prevented 59% of the instances of XSS in our data set. So there were over 3,000 commits in that data set. I forget exactly how many vulnerabilities that that resulted in. I should say those are commits related to XSS, not commits in total. The commit size in general for those repos was much, much larger. And like what we showed in the diagram from Facebook, yes, this doesn't mean that secure guardrails are going to eliminate all the XSS bugs, but we think that 59% in this example is a really, really impressive achievement that shows that adopting and using secure guardrails can have a really meaningful impact on reducing that, of course, the level of or the presence of XSS, but reducing the vulnerability backlog that people see. Now, we've seen not just XSS, of course, but many other things that people are trying to address when we talk to organizations and security teams who are trying to, or in many cases are already using secure guardrails in their environments. And so I just wanted to show you some examples. So these are anonymized but concrete examples of what our customers are doing today in terms of using secure guardrails. So these are, I think one of my favorite examples is the second one, enforcing the use of a custom encryption function. So this is an organization that is replacing, internally replacing the encrypt function with the organization _encrypt function. There are other things such as banning the use of the importing of specific libraries globally, or enforcing the use of specific role access checking before some types of user operations, prohibiting the use of hard-coded secrets, and recommending people to use things like secrets vaults and things like that, or secrets managers is definitely something that we see in common. And also one thing that's very interesting is kind of it related more to the developer education, providing documentations, reminders, kind of like more personal check-ins when there are certain types of things performed. Like in this case, when new API routes are added, oh, hey, there's a brand new API route. You should look at this documentation to understand what else you might need to do to fully make that live, to make it secure, who else needs to check on it, etc. So in many ways, some of the customers that we work with are using Semgrep to kind of aid in that education and that developer to security interaction. Okay, so we've talked a fair bit about secure guardrails. I want to just go back a little bit to kind of touch on how does this relate to what we were talking about when we were discussing shift left in the past at the beginning of the webinar. And again, I think what we're looking to do is kind of take the best of shift left and really expand on it, extend on it, and recognize that while developers do want to ship secure code, it's not enough to just take a security tool and kind of point it at them and expect that they will be successful. And so we're really trying to, with secure guardrails, put emphasis on not only showing issues to developers, not only making it that they only see critical and high severity issues, but also making sure that they have actionable issues that they are presented with, that we keep them in their workflow definitely as much as possible, and that the action that they are asked to take is really tailored, specific, in some cases even like specific to the project and the actual code that they're working on. So not just like, oh, this is unsanitized user input flowing into where it shouldn't, but specifically, hey, you are doing this in line X of code, and instead you should change that line to do Y, and et cetera, so that it's very, very kind of in context and relevant to the actual project that they're working on. This kind of maybe by implication means that they developers aren't required to have very high levels of security knowledge. Again, I definitely don't want to say that we don't want to educate developers about security. Just want to recognize that it can be counterproductive to expect them to or require them to immediately have that high level of security knowledge. And then One thing we found very, very useful is that the last thing here, the North Star metric. So in some cases, people look at how many issues are being, well, certainly opened, but then ultimately fixed. I think that that's important to track for sure. Also, it's important to track how many issues are being prevented from entering production, entering the backlog. And that will give us an idea of how security teams and really its security and development are gaining kind of control over their backlog, and how much or how are they able to really improve the level of security of their software that's being shipped. So we think one of the ways that we can benefit from secure guardrails is to enable or leverage it to fix issues early, to enforce policies. Now, those could be kind of like generally accepted best practices. They could also be things that are very specific to your organization. In your organization, maybe you want to do a certain operation in this certain way, and you want to enforce that. And that could be security related. It could be ultimately related to other things as well, like reliability or just general convention. And then ultimately drive people towards eliminating the entire classes of vulnerabilities because we're preventing them by construction. And what that means is that we're driving towards the kind of ideal state, let's say, of secure coding, code that is similar to what we mentioned that Google wrote in their paper, code that we know is secure because it is respecting certain properties and has certain characteristics, and therefore when it's going and shipping out, then we have complete confidence in its security, at least related to these areas that we're addressing. And that reminds me, I should say that a lot of these concepts are also found in more of the DevOps kind of cloud operations or CI/CD pipelines, workflows, templates, those areas where we've also seen a lot of good work in the area of sometimes called secure guardrails, sometimes called secure defaults. And what we've actually seen at some of our customers is that there's a lot of these best practices related to security in those areas that are now being more and more adopted by the application security team. Okay, I will pause here and see if there are any other comments or questions. Feel free to enter anything into the chat. Keeping an eye on time a little bit, and do want to speed up just a little bit and kind of show you a little bit of what secure guardrails look like in Semgrep. And the overall approach really is that we're trying to guide developers to do the right thing. And this really goes back to the philosophy or the Semgrep mission that I mentioned at the very beginning around profoundly improving software security. This is one example of, I think, of how that mission and keeping an eye on that really manifests in what we're doing in the product and what we're really helping teams to do. So traditional to security has been around checkpoints, tests, gates. I'm not suggesting that those should be eliminated and it's kind of like a free-for-all and now people are just speeding down the highway with no controls, restrictions, or monitoring. But instead, this is a shift in mindset that we are really guiding developers to do the right thing. And because we've mentioned developers many, many times in this last 40 minutes, it is important to consider what is it that developers really value in their tooling. And just wanted to highlight some of the things that we've seen that are common to many, many great developer tools, not necessarily related to security, just in general. One is around speed. Developers definitely value the speed of a tool. Maybe above all else. I'm not an expert in developer psychology or surveys, but definitely it's high up there. Transparency is also something that is highly valued, I think also by many folks in other parts of engineering as well. The ability to see and understand what is happening. Why is a tool or a thing behaving in the way it does? And then developer native really refers to the workflow that I mentioned before. Fitting into the developer workflow is very, very important, and respecting their kind of like UX characteristics and needs is really a characteristic of a great developer tool that is really one that fits into their style of working and the tools and platforms that they use. And we think that that is super important in order to successfully roll out secure guardrails as well. With Semgrep, we do give visibility into the developer engagement. So instead of this static screenshot, I'll just show you what this looks like in the product itself. And just wanted to show you a couple of graphs here that illustrate some of the things that we've talked about. So I'm going to just scroll down here and share with you a couple of these things. One is we can see here the total view of production backlog, the total number of opened issues over time. You can see over the last several months, we have a number of products in the portfolio. So these are broken out by kind of the type of finding that is present in the backlog. How many are fixed? I mentioned that earlier as a thing that many people track. It's important to track for sure. So we can see it here. And then the overall backlog activity, kind of number of new findings compared to how many findings are fixed or maybe ignored. And you can see here the trend line of kind of the net change. Of course, when there's many more new issues found or produced rather than how many are fixed or ignored, then the net change will go up. And in cases when there's fewer new issues compared to the number of fixed or ignored, then the net change is going to go down. So that's a way to really understand what is happening overall in the backlog. And then more specifically with respect to secure guardrails, we can see some information here around, one, how many of these findings are being shown to developers. And this chart, it looks like it's going up and to the right, but just do note the scale here starts at 0% and it's topping out at 12%. This way we can understand how many of these new findings are being shown to developers. And I think different people have different approaches to that. Some teams will want to have a look at the issues that are being produced, the findings that are being produced before they are shown to developers. That can be sometimes a little bit costly in terms of people power and the investment needed to kind of review those, and also may take a hit on speed. But if there's cases where teams really, really want to be careful about what they show to developers, and they're just getting started with kind of opening the aperture, let's say, of those things, then we've seen that. And then here we see findings fixed before backlog. This is something that many people have been really excited about it after I've shown it to them. And this is because they can see of the things that are being shown to developers in their workflow, yes, early on in the process, how many of those findings are being fixed before they enter that production backlog. And this is a great way to kind of understand how much of an impact is the rollout of secure guardrails having on the organization in terms of the backlog, and ultimately how it's improving the overall security posture. Okay, that's quickly what I wanted to share about what we see related to guardrails in the Semgrep platform. We can certainly go into a deeper dive if anyone wants to follow up and take a deeper tour of that. I also wanted to share just a few comments from our customers or people that we've talked to when we've shown them these kinds of things. One is that I'll just point out this middle one here. We recently published a blog post that really goes into the philosophy and the vision around secure guardrails, and there have been some great responses to that. And then the other one is around the statistics and actually directly related to the graphs that I was just showing, really taking the buzz out of the buzzword of shift left. So this person maybe would have been the only person who voted for buzzword in that first poll. Now, we're almost at the end of our time here, so I want to just take a step back and summarize what we've been talking about and what we're seeing in the industry. Ultimately, we're seeing that people need to kind of get away from the bug whack-a-mole approach and really start moving towards things that have a scalable impact on their security program. I also want to caution that I'm not suggesting penetration testing is going away or that bug bounties are going away or finding individual bugs are going away. It's just we cannot continue to rely on them as much given the constraints that security teams have in terms of their requirements for security, the way that they partner with ever-growing engineering teams, and the surface area of things that are needing to be secured. So teams are really looking for something else besides those things that will help them to really gain control of the backlog and improve the security, and really also improve the working relationship that they have with their software developer counterparts. So we see secure guardrails as one way to really improve that relationship. Again, the devil's in the details, just like it was with Shift Left in how this is rolled out. I don't want to gloss over that, but it's something that we have seen make a positive impact in that relationship, ultimately helping developers get to faster and easier remediation of vulnerabilities. And in what we've seen, let's say the best cases, enabling organizations to enforce their own specific best practices. Happy to share more details about that. That's something that we're really excited about as well. And we can also follow up with you at another time with respect to that. And if you go to the Semgrep blog and read that blog post I was mentioning earlier, that is also something that's very important to us and part of that vision. So lastly, I just want to end with a few resources that you can use. So you can sign up for Semgrep for free if you want to try it out. There's a link there, go.semgrep.dev/login. We also have in our Semgrep Academy a new course just around guardrails. And so if you go to that link there, you can sign up. It's free, and you can learn about secure guardrails in way more depth than we had time to cover here. And we welcome you to join our community. We have a Slack group. It's friendly. People, including I think most of the Semgrep engineering and security teams are there. People are helping each other. There's some conversations around secure guardrails there as well. And we are welcoming all of you to join if you'd like.